In this problem, we are given a list or a vector of numbers. It can be positive, it can be negative, it can have 0 elements. So we have to find 3 elements or triplets which sum to 0, and we have to return all such triplets, not just one. So how we can solve this? So we have already seen 2 sum problem. So we will use some hint from there, but let's start from beginning. So clearly we can have 3 loops, one starting from index 0, then second starting from I plus 1, and third starting from j plus 1. So we have to find 3 numbers, so have 3 loops. So we can look for all the possibilities, all combinations of 3 numbers, and see whether their sum is 0 or not. So this loop will execute n times, similarly this n times, so it will be order n cube. So at least we now have a solution, a naive solution of order n cube. So can we do better? So let's see what we can do. So immediate next thing would come that, so first was our n cube solution, which is kind of acting as an upper bound. So if you don't have any idea, you can start with a naive solution. And you see that this naive solution, where you look for all the combinations, all the possibilities where we pick 3 numbers, will yield a result in n cube. So we have an upper bound here. So we have to do better than this. So next can be that we sort this array. So let's sort it. So when we sort, it will get -4, -1, -1, 0, 1 and 2. Once we have sorted, what we can do, we can fix 2 numbers and try to find the third one. Here we had tried for all 3 numbers, all possibilities of I, j and k. Here we will fix first and second and try to find third. So what will be the time complexity for that? Sorting takes order n log n plus, so this we do individually. Then we fix 2 numbers, that is all values of I and all values of j. J will be from I plus 1, I will be from 0 to n minus 2. And then we will find for a third number. So these two will sum to some value. So let's say this array is A. So AI plus AJ will, whatever is this value, if we try to find the negative of this, so if this is sum, then if we find -s in this range, that is after j, that is j plus 1 till n minus 1. So it should be n minus 3, n minus 2, n minus 1. So we have to find -s in this sorted array. So finding in sorted array would take log n time. We can use binary search. So it will take log n time. And there are n square such possibilities. So n square log n. So here the time complexity is order n square log n. So we have improved. It was n cube, we came to n square log n. But can we do better, even better than n square log n? And the answer is yes. We can do it in order n square. So how we will do it? So once we have sorted this array, so let's look at the third method. So sorting will take n log n plus, we will fix just one number. Here we had taken all 3 combinations. Here we had fixed 2 numbers and tried to find the third. Here we just fix one number and try to find a pair instead of triplet. We are here finding a pair whose sum is equal to negative of this quantity. So let's say I is here. We fix the I for now. We will try different values of I as well. So now I is fixed to -4. So what is our task? To find 4 in this part. 2 numbers which sum to 4. So this sum to 4 and this is -4. So overall we will get 0. So this 3 sum problem reduces to 2 sum. And if the array is sorted, 2 sum will be done in order n time. So if you have not seen this, I will give a brief recap. So we have a sorted array. A1, A2, A3, that is it's in increasing or at least non-decreasing order. And let's say we want to find two numbers whose sum is k. So we start from here and here. If A1 plus A5 is less than k, then we have to increment the value. So this side is smaller, so we will move this to here. So that way the sum will increase since A1 is replaced by A2, which is more than A1. If the sum is more than the required sum, then we shift this to right to here. So this is left and this is right. Because this sum of left and right is more than k, so we will take next smaller value of r. So this will decrease somewhat. If it is still larger, we will come here. If it is smaller, we shift this one and we stop when these cross each other. So either we have found this sum or we have not found this sum. So this is linear time. So we will apply two sum n times. So first I is fixed here, try to find two sum in this part. Then we will move I here and find two sum in this part. So this will do n times, and this each two sum will take again n time. So overall n square time. So how we will implement it? So we can again you can do it in multiple ways. One would be that you keep storing the triplets, the value of I, j and k, not I, j and k, but ai, aj and ak, that is values stored at those indices in a list, but that may lead to duplicates. For example, in this case, this -1, -1 and 2, -1, -1, 2, these sum to 0. Then we come here and this is -1. So when we are here, there will be another solution as well. So -1, 0, 1. And then we move I to here. And again in this part also we have a triplet with sum to 0, and it's in this case same. So this -1 and this -1 are different, these two, but we have multiple of them. So the final result appears to be same for these two. So here we are getting 3 results, but in reality we have to return just 2 results. We don't allow duplicates. So how we can solve it? So either you store this triplet in a set of vector, hash set, or a set of list, whatever is required in the problem. So store it in a set, so this will eliminate duplicates, and finally while returning, return a list out of this, because the return type for this problem would be given as a list of list or a vector of vector, but these allow duplicates. So first we are storing in a set, and while returning we copy elements from set to a list or vector. But this is again this will work, and this is order n square only, but here we are doing this extra processing. That is, in worst case, if there are k solutions, then we will need to copy every element to this new list or vector that we want to return. Not in worst case, but in every case. So this extra copy thing creates some overhead. So can we do without it, without this set? Can we directly start inserting in the vector? So again the answer is yes. So let me redo it. So it was -4, -1, -1, 0. Then I think 1 and 2. So what we do, we start fix I here, and then find a tuple whose sum is 0. So for -4 we will not find anything. So next I is here, and we found we have to find +1. So we will do -1 and 2. So these will sum to +1, and this is -1. So overall it's 0. Then what we do, when we fix I here, there may be duplicates here. So if there are duplicates, then these will appear adjacent to each other since we have sorted the array. So when we had fixed this I here, then we had considered all the solutions where this was in the solution. So it will include all the cases where two of these occur or just one of these occur. So we would have also considered -1, -1, 2, and we would have also considered -1, 0, 1. That is all possibilities where this is included. So when there are duplicates, if we move I here, then it will repeat some solutions. Which solutions? Where this was occurring just one time. For example, this solution. So if we fix I here now, this is -1, then 0, 1. Again this solution will be repeated. So in order to overcome that, what we will do, when we start a value, we check that if the previous value is same as this or not. If it's same as this, we don't do it. So first time we will find the solution from here, and that will automatically include the solutions which we would have got when I was here. So next we come here, we see that previous solution is same, so we don't do it. Next we come here, we see that previous is different. So we now fix I here and then do it. So this was for I, but the same thing can happen in the case of J and other two values in finding the 2 sum. So in 2 sum, what we will do, so I is fixed, we are finding two numbers X and Y which sum to negative of this AI. So maybe these are duplicated. X is occurring multiple times, similarly Y. So when we reach here and here, their sum is minus AI. So we add it to result. Then we come here and we move this here. Again this will sum to this minus AI. So again we will add to the result since I is fixed. So again it will lead to duplication. So here also we will do that, check that. If till we find a new element, we keep doing left plus plus, and similarly till we keep finding same element, we keep doing right minus minus. So these are a few optimizations. So let's implement this ON square solution with optimization. The set solution would be much more easier. You just put everything in a hash set and finally copy that elements to a vector, but that will take more time. If n is less than 3, there are less than 3 elements, so you cannot return any result. So we return an empty vector. And we will sort it. And once we have sorted, we will iterate for all values of I less than n minus 2, since we leave last two elements for j and k. If nums I equal to nums I minus 1, then we will not do it. So this should not be equal. Or this for 0, this will not work. I minus 1 will be negative 1. So let's add a check there. For 0, we will always process it. So in these two cases, only we will process. Otherwise, if this is equal to previous element, then we have already the solution for that case. And j will be I plus 1 and k will be n minus 1. So left pointer, right pointer. If the sum is more, then decrement the right. If the sum is less, increment the left. So this will be same as finding negative of nums I. If sum is 0, then we found a solution. Then what we will do, result dot push back and after that there may be repeated values of j and k. In that case, shifting left and right, again we will get same value and we will again append to the result. So to avoid that case, what we will do, while j less than k, and so this check we will always add so that we don't overdo some problem. And finally we found a solution. So if we just increment j, then the sum will increase, so it will not be equal to 0. So we will both increment j and decrement k. And if sum is not 0, then it will be either more or less. Sum is more than 0, then k minus minus, else sum is less than 0, then j plus plus. And finally return the result. So the answer is wrong here. So there is a mistake here. It should be nums. Result is empty. We are sorting the nums. And the solution is accepted. And we are around here 55, around 112 millisecond. Now we will do it in Java and Python. And the Java solution is also accepted. Finally, we will do it in Python 3. and the Python solution is also accepted.